Hi, in this video I'm going to guide you to solve one homework question from section 8.3, and this question was asked by one of your classmates. So I guess I'll make this video to help you to know the step-by-step, because the other questions from this section are really similar to this type of problem. So section 8.3 is about testing a claim about a proportion. Now let's go over this example, and this one is one of your questions from MyMathLab homework week 5. So the question asks, a genetic experiment involving peas use one sample of offspring consisting of 42 green peas and 154 yellow. Now they're asking us to use a 0.01 significant level. 0.01 here is the alpha, to test the claim that under the same circumstances 26 of the offspring peas will be the yellow. Now remember, when we using the p-value methods, we are trying to whether we reject the null hypothesis or we do not reject the null hypothesis. So in this case, we are trying to test that 26% of the offspring peas will be yellow. Now 26% of something is the proportion. So in this section we are dealing with the proportion. So we are trying to test for whether we reject or we do not reject the null hypothesis. So I come up with the null hypothesis to be the proportion to be 0.26, because we are trying to test for 26% of the offspring will be yellow or not. So that means the proportion for the null hypothesis is 0.26, because we want to test to see if this is true or not. Now once we have the null hypothesis, what is the alternative hypothesis? So either that we get 26% or we do not have 26%. So therefore your alternative hypothesis should be the proportion is not equal to 0.26. So now we have the null hypothesis and the alternative hypothesis H1, and we also recognize that because the alternative hypothesis is not is including the not equal sign. So not equal sign meaning that this problem is the two tails. If we have something bigger than let me make a pen here. How do I draw the pen? Okay, I don't think I can make it in this video, but alright, but just know that if I have something that's not equal sign, then I have the proportion to be something maybe bigger than something. So if that is the case, then you have the right tail, because bigger than is this way, so the arrow is pointing to the right, so we have the right tail test. Or the proportion is less than something, then the arrow is pointing to the left, then you have the left tails. But in this case we have the not equal sign, then we have the two tail test for this problem. Now how do I find the test statistic? The test statistic has the formula given here, z, which is the point estimate minus p, which is here, over the square root of pq over n. Now the point estimate is, we are testing for the yellow. 26% of the offspring will be yellow. So I take the value of the yellow, which is 154, divide by n, or the total number of the offspring from the data, which is 402 plus 154. I got the point estimate p hat, which is 0.2770 in this formula. Now the p here comes from the original claim, or the one we're testing for, which is 0.26. Q is 1 minus P because P plus Q is 1, so Q equal 1 minus P, or 1 minus 0.26, and N of course is again this the same number here. If you plug them in all the formula here, you will get 0.914. This is for the Z or the test statistic. So remember, this problem is the two tails. So if you want to find the p-value, now you have to draw the picture. It's always a good idea to draw the picture so you know what is going on with the problem. So I have the p-value or the null hypothesis is 0.26 here. My test statistic is 0.914, and because I have two tails, so I have one for the positive and the other one is a negative, because this is the two tails. So we are looking for the area under the curve from the two sides, from the positive number go all the way to the right, and also the negative number and all the way to the left, because this is the two-tailed test. Now, how to find the area under the curve? You can use the table, the table A, I believe the table A2. So let me go back to the table here. Now this table is the negative z-score. So you have one is negative, and which is all the area from the left to some point z, or you have the positive z-score. So if you choose the z-score on the right side for the positive, then it counts from that point to all the way to the left. But we don't need this one because we only include the two tails, this left side and then the right side. Now go back to the picture here. They are symmetrical, so you just have to find one area, either this portion excuse me, or this portion, and then just multiply by 2, and then you get the both sides for the area. Now because we are trying to find the area here to the left side, so I have to use the negative z-score because it's count from that point to all the way to the left. So I have to pick the left point or the negative z-score, in this case minus 0.914. So if I go down here, minus 0.914, so minus 0.9 is this row, and 0.914. So 0.914 is between 0.91 and 0.92, which is these two guys here. So it's just the average of this number and this number. So if you add 0.1814 plus this number here, 0.1788, and take that number divide by 2 to take the average, you should end up with the area of this left region here to be 0.1801. Okay, let me try to find how do I write here. Okay, common. Yes, okay, so now I can write now here. So if you just use the table, if you just use the table here for the negative z-score, then I take the average of these two, I guess 0.1801. So this one is the area of this whole region here, and then because they are symmetrical, so I just multiplied this number by 2 to get the both sides for the area. So that number multiplied by 2, that's give me around 0.3602. So if we use the score table, we end up with something with 0.3602. Now, we don't have to use the Z table. All of you now should use the TI-83 or 84 to get a more accurate answer. If you do that, then we can find a p-value by just using the function called normal CDF. This one does the same thing for you as you was looking for the table. Now, if you use this one, make sure that you have to use the right command for this one, otherwise you get something wrong. So if I use a normal CDF here, this normal CDF just give you one area under the curve, and it has two inputs. The left side is the lower limit, the right side is the upper limit. So this is the lower limit of the left, this is the higher, the upper limit to the right side. So in this case, I want to find the area of this region. So I want to find the area from 0.914, which is the lower limit, and then my upper limit is all the way to the right, which is a huge number all the way to the right, and I input the huge number to my calculator to be 10 to the 99. This is a good way to represent something that is huge that your TI-83 or 84 can think of. So this is a lower limit 0.914, and then up to 10 to the 99 on your TI-83 or 84, and with the normal CDF function, you can click on the second and the vars, the input here. So how do I find this? I use the second button here, and then you click also the vars or the distribution buttons on your TI-83. So second, and then this one, and then pick the normal CDF and input the lower and the upper limit, and this gives me all the area, a good value for all the area under this curve. And the reason I multiply by 2, because I want to get the double area of this one, because this one and this one, they are the same thing, they are symmetrical. So I just multiply by 2. That's give me the whole thing, this side and then this side, because we are looking for two tails. Now if I do that on my TI-83-84, I get 0.3607. They are pretty much the same, right? But I just route it to 0.361. The reason is we have the TI-83-84 now, so it's very fast to just input the function and it will give you the value right away. You don't have to go to the table and look for the small number here and then take the average of the two, and sometimes it's not giving you an accurate answer. So I always recommend using this command from your TI-83 or 84. It will do a very good job for that. Now the p-value is 0.361. After you have the p-value, we are comparing that to the significant level, which is 0.01. In this case, 0.361 is bigger than the alpha. If we have the p-value is bigger than alpha, we do not reject the null hypothesis, or we do not reject the things we are testing right now. Okay, so we do not reject the H0, or we don't say that this is not correct, so we don't reject it. Okay, this one. Or you can conclude that there's not sufficient evidence to reject the claim that 26% of the offspring will be yellow, because the question is asked us to test the claim that under the same circumstances 26% of offspring will be yellow. So they just want to test if we reject it or we do not reject it. Okay, so in this case, the p-value is bigger than that. That means we do not reject the null hypothesis, or we say that we don't have enough evidence to reject it. Okay, so that is the conclusion from the p-value. We do not have sufficient evidence to reject the claim that 26% will be the yellow or the null hypothesis. Okay, so that is the answer for this question. So in general, we've found the null hypothesis here, alternative hypothesis, the test statistic, which is the z-score here, and then the p-value. However, if you got something less than 0.01, then the p-value is less than the significant level, then we reject the null hypothesis, or we say that there is sufficient evidence to conclude that this is not true, right? So it should be something that is different than 26% will be the yellow one. But in this case, we do not reject this because we don't have enough evidence. Okay. Now this is the case for the two tails. If something, some other question asks you to test the claim whether something that is increasing, like I mentioned before, if you say something is increasing or bigger than something, then you have something here and bigger than something. The arrow is pointing to the right. That means you are looking for the right tail test, or less than something, then you are pointing to left. That means you are looking for the left tails. Now in this case, whether we are checking if we have 26% or we don't, so I use the not equal sign, and not equal sign means that this is the two tails. Two tails, that means we're trying to look for the two areas under the curve to find the p-value. If just the right tail, then you are just looking for this side here, or the left tail, then you are looking for the left area. Now in this case, if I do not use the lower limit for here and the upper limit all the way to the right, I can always use the left side too, and I also multiply by 2. In this case, the lower limit for your commands here should be minus 10 to the 99 all the way to the left, and your upper limit that becomes minus 0.914. But I like to stick with the positive region, so let's just find the area on the right hand side here, multiply that by 2, give you the p-value. So that is the end of the solution for this type of problem, and I hope that it will give you some sense of the steps to work through the problem for this section, and also the next section, the next few sections of the chapter as well, because they should follow the same step and the same procedure if you using the p-value technique. Thanks for watching.